use your lab scope and a low current amp probe to do fuel pump amp testing. All these bad fuel pumps were found using amp testing, when regular fuel pressure and fuel volume testing missed them. Look at the wear pattern here, how deeply the brush cut into the commutator. And look here where the dark area is. The brushes weren't even making contact there. And that's what makes fuel pump amp testing so valuable. It finds failed fuel pumps that fuel pressure and volume didn't find. That doesn't say do one or the other. Fuel pump amp testing is best used in addition to fuel pump and volume testing. Use a vehicle-specific wiring diagram to find where to connect the low current probe. In our example, we have a fuel tank unit. You must place your probe in front of that unit, not between it and the fuel pump. So testing back at the fuel pump on these systems won't get you the correct waveform. On most examples, the easiest place to test is at the inertia switch itself. Look at our inertia switch here. We have a pink and a green wire. Our probe for our examples is going to be around that pink wire. First, measure the average current. Compare the current draw to specifications. The arrow at the top there is pointing to the center of the waveform. That is our average current. Our average current on this example is 6.8 amps. Now, our spec for this example was 4 to 7 amps. 6.8 amps is high. It's near its limit. If I saw this on a vehicle, I would look at the fuel filter to see if it's partially plugged. It needs replacement now. Here's a different example, just the opposite. The pumped current is near the minimum, 4 amps. And you can see our example, it's 4.1 amps. You don't want to fail the pump for being at the minimum. What you want to do is keep it in mind. If the engine is running lean and you can't find any other reason for a lean running engine, you'll want to keep this weak fuel pump in mind. But for now, let's continue to test. Next, you want to look at the difference between the highest and the lowest amps. And you can see here that the difference between our highest and lowest amps in our example does not exceed the maximum. And the maximum is 15% of the average current draw. In fact, we have a very good looking waveform here. If the difference is greater than 15%, don't fail the pump just yet. Once again, keep it in mind and continue testing. Locate the signature pattern on the pump's waveforms. Now, because the commentators wear in certain patterns, if you watch the waveform and then freeze the waveform on the screen, you can see where the waveforms will repeat, meaning that you can see the arrow on the left and then the arrow on the right. The waveform looks almost identical. This is the signature. That is one commentator bar coming around every time, making the same signature. Then place your cursors on those signatures. You can see our example, we have 8 commentator bars between our signature. That's one revolution of the pump. 8 commentator bars are average. Some high-end fuel pumps have 12 commentator bars. Some low-end replacement pumps have 4 and 6 commentator bars. Now measure it with time difference. The time in our example is 9.12 milliseconds, and it should not exceed 17.6 milliseconds. It shouldn't be less than 6 milliseconds. So what we're saying is the speed of the pump in milliseconds, the time it takes for a pump to do one revolution should be between 6 and 17.6 milliseconds. And what we're saying a different way is that means the pump's RPM should stay between 3,400 and 10,000 RPM. Here's how you determine the pump's RPM. You take the number 60,000. We get that number from their 60,000 milliseconds in 1 minute. You divide it by the time your pump takes for 1 revolution. Our example was 9.12. That equals 6,578 RPM. Our pump is within specs. Now, you've gathered some information. Use the 3 factors from the waveform to evaluate the fuel pump. Current draw and the RPM are the 2 most important factors. Current draw. If current draw is near the high end of the spec, check for the fuel filter like we talked about. The harder the pump works, current draw, the higher the fuel pressure volume will be. If current draw isn't within specifications, go find out why. Go to fuel pump circuit testing. The difference in the highest and the lowest amps is an indication of the fuel pump's internal circuitry. It's not a good practice to replace a fuel pump based on what you see in the highest and the lowest amps. We've seen some very ugly waveforms where the fuel pump was watched after it was released back to the customer, and it lasted several more thousand miles, in some cases 30, 40,000 additional miles. So it's not a good practice just to replace it because you have an ugly pattern. Okay, fuel pump RPM. Now, if RPM's too slow, you need to check current draw. You need to make sure that B plus and ground for the pump are good. If the RPM is too high, it's simply spinning too fast and not delivering enough fuel. So in that case, if it's going too fast, just replace the pump. Fuel pump current waveform testing has proven to be one of the most productive tests we have ever used on fuel pumps. Take time to learn the procedure. At minimum, measure the current draw with an amp meter.